Bismillahirrahmanirrahim. Dear students, we are drawing to number 12, chemistry, and lecture number 69, grade 11. Grade 11 chapter number last chapter 12, lecture number 69, and determination of cell potential according to the electrochemical series. According to electrochemical series. Yesterday I told you that standard hydrogen electrode consists of platinum wire finally divided by platinum surrounded, immersed in 1 molar solution of hydrochloric acid and pass hydrogen gas at 1 atmospheric pressure. So its cell potential is 0. Standard hydrogen electrode, if it oxidizes or reduces, its E0 cell for the hydrogen is 0. According to the electrochemical series, all the reduction potentials are given. On the top, reduction of Hofstadter reaction for the metal ions, they have in the negative. So in the previous lecture I told you, if any Hofstadter has large value in negative, is called, it should be oxidizes, it acts as an anode, and large value of positive, it is going to be reduced and it acts as a cathode, where the hydrogen is in middle, which has a 0 for the oxidation and 0 for the reduction according to the table number 12.1. So we use this electrode potential. So how we determine the determination of cell potential? How we are going to determine the cell potential? So cell potential according to the electrochemical series, I am going to write this one. First simple example we done for the Daniel cell. So in the examination, maybe the examiner give like this one, reduction potentials. Zinc, positive 2, zinc, this is reduction. And E0 cell for the zinc is plus 0.76 volts. Reduction potential for the zinc is minus. Copper, reduction potential, E0 cell is plus 0.34 volts. These values will be provided in according to the agreement IUPAC system. So these will be given provided. Reduction potential will be provided. So by using these reduction potentials, you have to write first Hofstadter reactions complete. Zinc, positive 2, copper 0 to give copper positive 2 ions, and zinc 0. Here zinc positive 2 electrons to give zinc metal, E0 cell is equal to minus 0.76 volts. Copper positive 2 electrons reduce to give a copper metal E naught cell plus 0.34 volts. In this form I have written. Maybe the examiner asks you that is zinc displaces of copper or not? Is the zinc displaces copper from the copper sulfate solution or not? So according to the electrochemical series, you can see the values of reduction potential for both. The value is negative minus 0.76 volts and plus 0.34 volts. According to the rule you done, the potential which has a more negative is going to be oxidized and more positive is going to be reduced. So you can see zinc is going to be oxidized and copper is going to be reduced. That's why the zinc is going to be oxidized and copper is going to be reduced. So we write zinc 0, changes in zinc positive 2 by the loss of 2 electrons, E naught cell plus 0.76 volts. Zinc is going to be oxidized according to this equation, this given. Is zinc displaces copper from the solution or not? According to this information, reduction potential which are given in the table. So the formula we use here, calculation of cell potential, E naught cell for the cathode means reduction and minus E naught cell for anode oxidation. Use this formula, put the values. E naught for cathode copper is plus 0.34 sign minus, and when you put here, then you have to put the original value, which is a reduction potential value, original one. Reduction potential value you have to put here. This will be a minus 0.76 volts. If you are going to solve cell potential plus 0.34 volts minus into minus plus 0.76 volts. So the answer, if you add both, you will get 1.10. If you add 0.34 plus 0.76, so 1.1. The answer is plus 1.10 volt. Dear students, there is one thing very important. If the cell potential, if this cell potential in the last positive, the reaction is spontaneous redox reaction, spontaneous, and it is feasible. Reaction is spontaneous and feasible, means this chemical reaction will happen, and zinc can displaces copper from its copper sulfate solution. Zinc can displace copper from the copper sulfate solution. The reaction is feasible. If your answer is negative, cell potential comes negative, the reaction is not feasible and non-spontaneous redox reaction, the reaction will not happen. Maybe the question asks that, is this chemical reaction is spontaneous or not? So we have here other examples also. I am going to solve. This is number 1. I have done this. The answer is plus 1.10 volt. So you have to write very well. Now we have more examples. I am going to solve. If you see your book, example 12.11, the standard reduction potential, the following Hopf reactions are given below. Calculate E naught cell for nickel and magnesium cell. Write cell reaction, show direction of the reaction flow and identify the anode of the cathode. Dear students, here magnesium will act as an anode and nickel will be act as a cathode. It means that the reaction is like this. Is this chemical reaction spontaneous? Give the direction of also chemical reaction. So magnesium plus nickel to give magnesium ion and nickel 0. So here in this cell, first I am going to give you answer. Magnesium is going to be oxidized and nickel is going to be reduced. Means magnesium can displace nickel or not. Magnesium can displace nickel or not. So according to information given here, the reduction potential according to the electrochemical series table, nickel reduction potential is a minus 0.25 volts and the magnesium reduction potential is a minus 2.38. Minus 2.38. It's very clear now. More the negative, higher the negative reduction potential value will be oxidized. So we got the answer. High negative value for the magnesium, low negative value for the nickel reduction potential. So magnesium must be oxidized and nickel must be reduced. So that is why magnesium acts as an anode. There is oxidation at anode. Nickel is going to be cathode. Reduction taking place from the cathode. Electric current flow from anode to cathode. The direction of electric current will be from the anode to cathode because magnesium is going to be oxidized and nickel is going to be reduced according to reduction potential value. So I am writing here reduction potential according to the electrochemical series. Magnesium Magnesium metal. Cell potential for magnesium is minus 2.38 volts. Minus 2.38 volts. Nickel. Cell potential for nickel half cell is a minus 0.25 volts. So it's clear. It is clear that magnesium has a greater negative value, minus 2.38 volts. That's why magnesium will be oxidizes and the nickel will be reduced. So write the half cell reaction here. Magnesium is going to be reduction potential. Cell potential of cell minus 2.38 volts. Nickel reduce 0. Standard cell potential minus 0.25 volts. So this I write this in this form. Now here magnesium is going to be oxidized. So magnesium 0 changes into magnesium positive 2 by the loss of 2 electrons. E naught cell sign is going to change, plus 2.38 volts. Because in this magnesium is going to be oxidized and nickel is going to be reduced. These will be provided for you. Reduction potential will be provided for you. Then you have to decide according to this equation. According to this equation, you have to decide either magnesium is reduced, oxidized, this oxidized, and this reduced. So I write the oxidation reaction and the sign is going to be changed. Then apply this formula. E naught cell for the cathode minus 0.25 volts. So sign is minus. Then I told you put the original value. This is the original. 2.38 volts. So E naught cell minus 0.25 volts, minus or minus plus 2.38 volts. Then you have to subtract 2.38 minus 0.25. You will get plus 2.13 volts. So dear students, this is a plus. The value is plus. So the reaction is spontaneous redox reaction and it is feasible. It means magnesium can displace the nickel from its solution according to the reduction potential values given in the electrochemical series table. The reduction potential which has high negative value, which is going to be oxidized, which has a more positive value, is going to be reduced. So this is a procedure how you calculate. I am going to solve more this is the exercise. Self-check exercise 12.7. Self-check exercise 12.7. You have to use the same formula. Self-check. The standard reduction potential copper is E naught plus 0.34 volts. Chlorine is plus 1.36 volts. The question is that calculate the cell potential for copper and chlorine cell. Write cell reaction, identify cathode and anode, show the direction of flow of electron, and this reaction is feasible or not. Same I am telling you that from these values according to electrochemical series, we can decide that the reaction is spontaneous or not. Copper 0.034 volts and chlorine is 1.3. This is very clear. Higher the positive value will be the cathode reduction, less will be the positive value acts as anode. It means that copper will be act as anode. It is going to be oxidized, and chlorine is going to be reduced. So that's why I have to change this according to these reduction potential. Less value in positive, more value in positive. So this will be oxidized, this is going to be reduced. So copper ions. So E naught will be minus 0.34 volts. It's going to oxidize. So write the chemical reaction. Copper plus chlorine to give copper chloride like this one. Copper is going to be oxidized and chlorine is going to reduce according to these values. So the answer is that copper is going to be oxidized, so it acts as an anode. Copper anode, chlorine cathode. Electrons flow from copper to chlorine, from anode to cathode, from oxidation to reduction. This is the answer. Now I am going to calculate the value. Cell potential for cathode. For cathode is plus 0.34 volts. E naught cell plus 1.36 volts minus plus minus 0.34 volts. So calculate it. 1.36 minus 0.34. The answer is 1.02 plus 1.02 volts plus indicates that the reaction is spontaneous Bloch's reaction and it is feasible. Means copper can reduce the chlorine and itself oxidizes. So this is the reaction, feasibility of the chemical reactions. Whether the chemical reaction is feasible, occur spontaneously or not. The positive sign indicates when we add both the feasible reaction, and negative sign indicates the reaction is not feasible or non-spontaneous. There is another one, and you have to solve yourself exercises questions also. So the example you have to do, this is simple. I'm going to do in self-check 12.8. Self-check 12.8. You must calculate at your home. Because this is the last topic of the syllabus, then syllabus will be completed according to the reduced syllabus provided from the Federal Board Islamabad, and you have to revise many times. Self-check 12.8. Using the EMF data, explain the following. Can iron displaces copper? Can iron displaces copper from copper sulfate? Write that equation. Can iron displaces copper from copper sulfate solution or not? Is this chemical reaction is feasible or not? Spontaneous or non-spontaneous? This is the question. So dear students, it means that iron is going to be oxidized and copper is going to be reduced. Iron is going to be oxidized and copper is going to be reduced. So in our cell, iron positive 2, iron metal, E naught value for iron is minus 0.14 volts for iron, 0.44. Minus 0.44 volts for the iron, and for the copper, reduction potential of copper, E naught value is plus 0.34 volts. So we have to calculate that iron will displace or reduce the copper or not. So I am writing half cell reaction for reduction of cell reactions. Iron positive 2 electrons. This reduction potential according to the table is minus minus 0.44 volts, and copper two electrons, copper solid, E naught value plus 0.34. This is according. This can be written in this form. This is given. This is reduction potential. This reduction potential. But here iron is going to be oxidized, so I am going to change. I am going to change. Now iron is going to be oxidized. So there is oxidation in iron. E naught value will be now plus like this. By using the formula, by using this formula, E naught cell for cathode, E naught cell for cathode, this is the copper plus 0.34 volts, sign is minus, and actual value for iron is minus 0.44 volts. So E naught cell plus 34 minus into minus plus 0.44. So students, 0.34 plus 0.44, the answer is plus 0.78 volts. So the reaction is spontaneous. The reaction is spontaneous and feasible. Means iron can displace copper from the copper sulfate solution. The answer is yes. The answer is yes after doing whole procedure. This is the first answer. The second is write while this must write, must solve, very careful solve at home. Dear students, the question is, second question is 12.8 said, can iodine displaces bromine? Can iodine displaces bromine from aqueous solution of potassium bromide. This you done in the grade 9. You have done the grade 9 also. So this is the question. We have to give the answer yes or not. No and yes may jawab dena. So you will get potassium iodide and bromine. Like this. Can iodine displace bromine from potassium bromide or not? It means that iodine is going to be reduced and bromine is going to be oxidized. According to this, you have to give the answer according to this one. Is yes or no? So iodine, see the table. See the table for value, reduction potential values for the iodine and chlorine, yes. Iodine, solid, reduction potential. E naught for iodine is plus 0.54 volts, and for the chlorine, is plus 1.36 volts. Yes. Now students, these are the reduction potentials given in the table. According to this, iodine is going to be reduced. Okay, this is the reduction potential of iodine. But bromide is going to be oxidized according to this equation. Don't see the value. According to the equation, according to the question asked, can iodine substitute or take place or going to be oxidized bromine or not? So I am going to reverse it. Bromine, not chlorine. This is the bromine. We have value for bromine also. The value for bromine is E naught value plus bromine 1.09 volts. Okay. So bromine is going to be oxidized, so I am going to change. This is oxidation. So E naught is minus 1.09 volts because bromine is going to be oxidized here and iodine is going to be reduced here. Now according to formula, E naught cell for the cathode means reduction, so iodine is going to be reduced. So the cathode is a plus 0.54 volts, the sign is minus, and original value for bromine is plus 1. 1.09 volts. So this will be a plus 0.54 volt minus into plus minus 1.09. So students, 1.09 minus 0.55, but answer is minus 0.55 volts minus, so no. The answer is in no, negative, not feasible, non-spontaneous. Answer is no. Iodine cannot displace bromide. I am from the potassium bromide. And you done in grade 9 the reactivity. Fluorine is the most reactive. Fluorine is more reactive than chlorine. Chlorine is more reactive than bromine. Bromine is more reactive than iodine. It means that fluorine can oxidize chlorine, chlorine can oxidize bromine, bromine can oxidize iodine, iodine cannot oxidize bromine. Iodine cannot oxidize bromine. The reaction is no reaction take place and no substitution taking place here according to the electrochemical series. Very dear students, we are going to finish here activity series. Tomorrow I will also give you one lecture about the activity series of writers. Last lecture will be here, so inshallah I will complete. You have to solve all the exercises, questions, and also you have to solve the numerical problems where you will find in the syllabus. Solve the Federal Board previous papers according to your reduced syllabus. So inshallah tomorrow I will give you last lecture. Thank you very much.